Hello, friends, and hello to everyone. So, before going to the programming of MPMC, okay, this is very important basic topics that we have to learn while writing programs, because we are not writing directly to the processor, because 8086 is a microprocessor, so we don't write directly to the processor. So, in between a processor and the programmer, there is one more part which is essential for us, that is assembler. So we'll communicate it to the assembler converts the code into a meaningful language which is understandable by the microprocessor. So and it starts executing the program. Okay, so first thing, as a programmer, we have to understand that we are not going to write it for the processor, but we are writing it for the assembler. Okay, there are many assemblers, assembly level languages. Okay, they are, one is a TASM, second one is NASM. Many things are there, but most probably we use these two things, that is TASM and MASM. But in our college, we use TASM software as turbo assembler. As a turbo assembler. TASM means turbo assembler. Clear? So as we are writing for a assembler, as we are writing the code for an assembler, so whatever we are writing it, it has to be understood by the assembler, and it has to convert and communicate to the processor. So that is what we use to write. We are going to write down the assembler directives. Okay, that is the reason we are going to write down some assembler directives. So assembler directives are something like special code placed in the assembly programming to instruct the assembler to perform a particular task. Okay, clear? So they can be like defining a symbol, value, reserve the keywords, or initialize storage space for variables, and control the placement for program codes. Okay, clear? So there are different types of assembly directives. The assembly directives are some, as we have said in previously, there are space for variables. So they are called as there are 5 different storage type of variables. That is, variables can be defined when I want to represent the data. The data can be represented in the form of variables. Okay, so the variable may be A, B, C, D, E, F, and something like that. So while we are defining the variables, we use these 5 different types of storage types. Okay, the storage types are DB, define a byte. We'll explain each one clearly. Define a byte. DD, define double word. DW, define word. Okay, DQ, define quadra word. DT, define 10 bytes. Clear? Define a byte means the size of the byte will be only 1 byte, that is 8 bits. Define a word means the size of the entire variable, what we are declaring, is of 1 word, that implies 2 bytes. 2 bytes, that is 16 bits. Clear? Define a double word means it is of, what is that? It is of 2 words, that implies it is 32 bit. So 32 bit means it is 4 different bytes. And define a quadra byte means 4 words. Quadra word means 4 words. So 4 words means 64 bit. So it is approximately 8. So it's not approximately, it is exactly 8 bytes. Clear? So in the same way, we have defined 10 bytes. Sir, you may have a doubt saying that, okay, sir, we have, as it is a 16-bit processor, we use a byte, we use a word because it is a 16-bit processor. We use a double word, maybe in some cases. We may use a 64 words, but what is the reason that we are using 10 bytes? Define a 10 bytes. Because we have in 8086, there is a term called long also. Okay, so when I want to multiply large values, or when I want to do some calculation using large values, okay, then we go with this type of what is called 10 bytes. Clear? So there is specific reasons, because a large type of multiplications cannot be performed with a 64-bit or a double word or 32 bits. Okay, clear? So we have to define the word with the 10 bytes. There may be chances. Okay. So some of we have seen as basic types. Okay. Now, there are some other things that we have to learn in assembler directives. There are many things, but we discuss only a few which are very, very essential for our programming. Okay. Remaining things you can look at the book. Any standard test book, we will be finding it out. Okay, clear? So, assume is one keyword, one word that is used for assembly directive. Okay. It is a directive used to tell the assembler that the name of the logical segments. Okay, segments, we have already discussed about segments. In 8086 there are 4 different types of segments. What is the reason that we have only 4 different types of segments? Why we have to specify the segments? We have learned already in the classes. Clear? So the 4 different types of segments are called as CS, DS, extra ES and SS. They are code segment, data segment, extra segment and stack segment. Clear? So here we have mentioned all these things. Clear? So the moment I say assume CS hyphen code, it tells the assembler that the logical segment named code contains the instruction statement for the program that should be treated as a code segment. Clear? So the moment I say assume CS hyphen colon code, it tells the assembler that the logical segment name code contains the instructions of statements for the program should be treated as a code segment. Example I'm taking, assume DS, assume CS colon data. Okay, this tells the assembler that the logical segment named code contains the instruction statement for the program that should be treated as code segment. In the same way, data, whatever we have written in the particular data, that is treated as data segment. Clear? So now we go back to the actual state. DB, we said defined byte. It is used to declare a byte type of variable and store a byte in the memory locations. So like Bryce, DB, this is a variable that we are going to use. 49H, 98H and 30H. Here we are declaring array of 3 bytes named as price and initializes the entire memory with these types as 1 byte carries 49H, 2nd byte carries 98H and 30H and the consecutive levels. Okay. If the second example is name DB single quotes A, B, C, D, F. Declare an array of 6 bytes. Why I am saying 6 bytes means it is an ASCII code of form. Okay, ASCII code for letters. So each letter occupies 1 byte. Each letter occupies 1 byte in ASCII codes. Okay, clear? In the memory, each byte occupies one word. Okay, clear? So there are defined word and so on. So okay, clear? So the point over here is now when I am going to write down any program, the first thing is we write down assume, and we will also write down what are different bytes, words, and something like that. Okay, define word, and I'm declaring a variable. Now, when I first write down the program, the first thing is we usually write down assume keyword, because what are the segments that I'm going to write down? What are the segments that I'll be having? Those segments should be given a name, that is CS colon code, DS colon data, ES colon extra, SS colon stack segment. What are segments I'm going to write it down or I'm going to use it in the program? Those segments have to be written in the assume keyword. Clear? So, for example, if I'm going to use only 2 segments, like they are essential for us while writing the program, the essential parts are code segment should be there and there should be data segments. Stack and extra segments are only used when I want to write down, when I want to use a stack segment or when I want to use an extra segment. Clear? So, but these 2 different segments are very, very essential. Okay, that is assume cs colon code comma ds colon data. Clear? So we have written that in the program something like this. Okay, something like assume code ds comma data. Clear? Now, by writing this, if we have intimated to the assembler that okay, I am going to use a code segment and I am going to use a data segment. Clear? Now, the point is where I am going to use a data segment, what is the starting address, and where I am going to use the code segment under the starting address. Clear? So while writing it down, the point over here is, the first thing is we have to define that where I am going to write the data. So the data is defined by like this, data segment, where segment is an assembly directive. Clear? So the moment a keyword followed data followed by a segment, it says that this is data segment starting point. Whatever we want to write it down, I can write it down in this particular data. And the moment I close this data segment, then it has to be written as data ends. These whatever I written, whatever I'm going to write it down in between data segment and data ends, that is considered to be a data. It may be defined in a variable using some keywords or whatever it may be. Clear? Now, in the same way, now I write down code segment and code ends. Okay, whatever I'm going to write it down in between these two things, we say that it is the code segment. But will the moment I write down code segment, will the assembler program starts thinking that this is the code segment, so I have to consider it as a code segment? No, it will not take it like this. Okay, so there is one directive which is very, very essential, that is start. This is the point where real code starts. Now, whatever instruction that I write after giving the name start, that is considered as a real code segment, real code. Clear? So the moment I say I have started the code, so I have to even end the code. So what I will write down, end start. Clear? So I have to write down a data segment, data ends. So if I use an extra segment, then what I will write down, extra segment and extra ends. If I want to write down stack segment, stack ends. Clear? That's what. Clear? Are you able to understand this particular logic? So for writing a code, there are again two words that I have to write down, start and end start. Because all these three, that is data, extra and stack, are all data segments. So we write only stack, data segment, data ends, extra segment, extra ends, stack segment and stack ends. Clear? So now the point is, you'll go back. Okay. There are many other points, that is end program. While ending the program, we'll write out end start. So end P is ending the procedure. Ends is we have already, it is ending the segment. EQ is to equate, even, align and even memory for doing some calculations. Extend specifies the symbol that the current source file uses, but which are defined in other object. That is, they have specified a symbol which is used in another object, and we want to call this one. And labels. A place at the beginning of the statement gives the current value of, we'll use some labels in the program, okay, as the programming is there. Then we'll specifically know about each and everything. Clear? It gives the current value of the active location, counter, and serves as an instruction operand. Clear? So there is a name, offset, origin, org, procedure, pointer representation, segment, what we had discussed earlier, short and type. Clear? So there are other things which we want to discuss, that is DOS function calls. So DOS function calls are, if I write down AH00H, it specifies that we are going to terminate a program. AH01H specify read a value from a keyboard. AH02H write to a standard output device. AH08H specifies that read to a standard input device without echo. AH09H displays a character string on the screen. AH0AH display buffered keyboard input, and this is the instruction that we are going to write down everywhere. Clear? That is INT21H. That is, it calls DOS functions. Clear? So with this, when we enter into the program, okay, we'll be very commonly use all these particular different assembler directives. Clear, Andy? So now first we have to know about these functionalities, then it will be very easy for us to write down the instructions. Clear? And there are many instructions that we have discussed in the class. To your feasibility, if you have forgotten about all these things, I will be placing the links for all these what is called instructions. First look into the instructions, then come back, so that you will be able to see, or you're able to write down the program perfectly. Okay, the logic is important for us. If you know the logic, everything is very easy for us. Thank you.